So it gives me great pleasure to welcome our speaker today, Tom Thurlow, who's a member of our Exmoor National Park team. He's our Historic Buildings Officer. And I have to say, Tom has been very busy over recent weeks overseeing the installation of secondary glazing in our offices at Exmoor House in Dulverton. And it's made a real difference to our office, I can say. I was in there on Monday, just after the work had been completed, and it felt much warmer. And they look very sensitive to the historic significance of the building too. So I'm sure we're all really keen to hear what Tom has to say about this, perhaps, and other suggestions for improving energy efficiency in historic buildings. So I'll now hand over to Tom.
Thank you very much, Shirley. I've just requested control from your machine. There we go. Excellent. Hello. Yeah. Perfect. Thanks. I've got it. Hello. Yes, hi. I'm Tom Thurlow. I'm the Historic Buildings Officer for the National Park, and I was actually asked by our leadership team to do an energy efficiency briefing for our National Park Authority members, because it was something which they felt would be useful. And then it kind of rolled, and the National Trust wanted a talk, and now I'm speaking to you guys. So there's clearly quite a lot of interest in this subject at the moment, and that's understandable, really, given the climate crisis that we're in. And I'm sure you've all seen on the news all the Insulate Britain protests blocking the roads and so on. So hopefully you'll find this a useful hour or so, with some useful examples of how buildings which are older can be improved and made more energy efficient. Right, so if I go to the next slide. So Exmoor, I'm going to be focusing mainly on examples in Exmoor, obviously. Clearly the building stock on Exmoor is predominantly older. If you think of all the village settlements that we have, which make up the majority of the houses, they are fundamentally medieval settlements, and they have medieval houses in. So there is really not very many modern buildings in the national park. We don't have precise figures, but I mean, I kind of did a round ballpark figure of probably more than 75% are over 100 years old. So making these buildings more energy efficient is a huge task, and doing it properly and respecting their historic significance can cause challenges. So these are sort of things which I'm sure you're all familiar with now. These Insulate Britain protests taking place, blocking the roads, and these sort of energy audit surveys, which we see in newspapers, showing the heat loss out of buildings. And what can be done about these matters is very complicated. And I do have concern that a lot of people kind of oversimplify the issues here, and they think it is just a case of putting in new PVC double glazing or putting in loft insulation, when there are many other things to take into account. So obviously there's a huge drive at the moment to cut greenhouse gases, and the government has committed itself to an 80% cut on 1990 levels by 2050 in the Climate Change Act, which is a huge amount. And 45% of CO2 emissions generated in the UK come from energy use and day-to-day building operation. So that's a massive proportion of our CO2 emissions. Across the country, this is residential buildings, around 4 million or 20% were constructed before 1919, and around another 20% were constructed in the interwar period. So that's a massive amount of buildings. It's huge. The government has estimated the total energy consumption, energy consumed by the average UK dwelling. 60% is for heating, 21% for hot water, 14% for electrical appliances. So these buildings, if we target them properly and do put the correct energy saving measures in place, will have a dramatic impact on the UK's CO2 and greenhouse gas emissions. But obviously, as I've said, we have a large amount of historic buildings, and trying to put these measures in place in a way which not only doesn't harm the significance of the building, but doesn't prevent that building functioning properly is tricky. So when I'm talking about historic buildings here, I'm not just talking about listed buildings. Listed buildings have a special designation in place, which they are deemed to be of special architectural or historic significance, basically. But only around 2% of buildings in the country are listed, so that's a very, very tiny proportion. And a point I think is very important here is that many of these older buildings actually have a very low amount of embodied energy in them already. So if you think of a cob and thatch house in Selworthy, for example, that cob probably came from the field that the house was built in. The thatch probably came from the field up the road. The timber frame came from the wood behind. So there's a very low amount of energy that's gone into constructing that house. So in one sense, that building is very energy efficient already. I take a lot of my guidance on this from Historic England. They have a huge amount of free information available online. This is just a taste, really, of some of the subjects that their guidance covers. And their guidance is very detailed and usually comes from university studies. So it's really reliable, really in-depth, although it's technical, it breaks it down into its simplest forms as well. So for pretty much any aspect of building work where energy efficiency improvements are needed, I consult the Historic England guidance where possible. Now, Exmoor National Park, I won't dwell too much on our policies on this, but that policy highlighted in yellow basically is the important one. So we have this policy on conserving heritage assets, and where proposals are needed to adapt to or mitigate the effects of climate change, these will be permitted, provided that it safeguards the interest of the heritage asset over the longer term. So every historic building is different, and that's why they're so fantastic, really. And because they are different, it means that every building has to be treated individually when you're looking at measures to improve its energy efficiency. And the really important first step is trying to understand the building that you have, understand what is important about it, understand what its key significant features are. So you look at the heritage value, so you understand how your approach to improving the energy efficiency of the building may cause harm, basically. So obviously, if you have a building which has 400-year-old timber mullion windows in it, taking those out and putting in new timber double glazed windows probably isn't the best first step if you haven't got any loft insulation, for example. So it's looking at how you can approach the building in a way that affects its significance the least, basically. There's all sorts of other things to take into account as well. So setting, archaeology, where the services may run, for example, if you're considering an air source heat pump or something, which I'll come on to. All these things need to be taken into account. So you're probably all aware of energy performance certificates. These are things which are required when a property is built, sold or rented. There is an exemption. And that exemption I'll come to, but basically the EPC gives a rating so that comparisons can be made between the energy performances of different properties. And the minimum energy efficiency standard was set at E for rental properties in England, but the average in England and Wales is around a D. And you'll see on that colour chart there that D is pretty much smack in the middle. So there are exemptions to energy efficiency, energy performance certificates. And the exemptions are listed buildings, places of worship, temporary buildings, rented or holiday accommodation used for less than 4 months a year. So the key one there really is the listed buildings exemption. This only kicks in though when the requirement to make it meet the minimum EPC would lead to an unacceptable alteration to that building. So if you've got a building which is a G and listed, and the only way to get it up to an F or a D would be to put in UPVC double glazing, you just won't be able to do that under the current Historic England guidance on what's acceptable for works to listed buildings. So that's where the exemption kicks in, really. A really important point to take into account here is that quite a lot of assumptions are made when EPC assessments are produced. So for pre-1900 buildings, an assumption is made that all ground floors are suspended, which obviously isn't going to be the case for many older buildings. Many will have solid floors. They'll assume that all walls are the same thickness, which obviously isn't going to be the case for older buildings. And they will also assume, bizarrely, that all roofs are tiled or slated and that there is no draft proof. Historic England formerly English Heritage, carried out a survey in 2007 and actually found that the energy use was 40% less on average than the EPC rating conveyed. So if you're struggling to get up your EPC bands, then a really good thing to do is have the building re-audited, professionally audited, and they can provide a much more in-depth survey of the building and give you a much more accurate energy efficiency rating, because it may actually mean that you don't need to do any works to get that building up the EPC bands. Building regulations is not something that the National Park deals with itself, but will need to be met when you're going to be doing works to buildings, certain works to buildings. So if you're going to do extensions, change windows or so on. It's part L1B, which is the important one in this respect. So this is conservation of fuel and power in existing dwellings. And this has exemptions in place for certain classes of historic buildings. So it expressly exempted from the need to comply with these energy efficiency requirements, where the compliance again would unacceptably alter the character and appearance of the building. So again, building regulations will have a part in it saying it has to meet this energy efficiency rating. And if I use the same example of UPVC again, if you're building an extension and the building control officer says you have to put in UPVC windows and it's a listed building, then that can be overcome by that little sentence, basically, that, in my view, it would unacceptably alter the character and appearance of the building. So the other exemptions in that are listed buildings, buildings in conservation areas, and scheduled ancient monuments. Now, scheduled ancient monuments generally aren't buildings which are lived in. So the listed buildings and the buildings conservation areas is the important one there. But there is a further paragraph which says there are other special considerations which apply, and those include locally listed buildings, buildings of architectural or historic interest within national parks, which is a really important one. So that covers a huge amount of the buildings on Exmoor. So if you're having issues with building control officer saying you need to get your building up to energy efficiency regs, and you're unhappy because you think what he's asking, he or she is asking for, may unacceptably alter the appearance of the building, then speak to the national park, and we can go back to the force of the building control officer and make clear we have concern about that. And that really relates to that bottom paragraph there, really. So it's important, and this is in the actual regulations document, it's important that the building control body takes into account the advice of the local authority's conservation officer. So for listed buildings, historic buildings, that is myself. So where I have a concern, the building control officer has to take into account my view when coming to their decision. And this is an example of one such case. So this is a grade 2 listed building, and the owners carried out some works with listed building consent and all planning consents in place, but unfortunately didn't consult with the building control officer. And the building control officer visited. Unfortunately, it was too late. They'd already done a lot of the works, but they hadn't insulated the extension properly, basically. So the building control officer said, right, well, in that case, you're going to have to change all of your windows to double glazed, and you're going to have to take up this historic floor here and insulate underneath it. At which point they contacted me and said, are we allowed to do that? And I said, no, you're not going to be able to do that. And there was a lot of backwards and forwards with the building control officer on this, who eventually realised that it was completely unacceptable to do those works to a listed building. So unfortunately, another solution was found in that case. A really important first step is making sure that your building is in good condition. There's no point doing a lot of these works if it's not. So if you're thinking of putting solar in or a new ultra efficient boiler and your roof is leaking heat or your windows are rattly, it's just wasted money, basically. So that's a really important first step to take into account. Get the building functioning properly. Which brings me on to that second point, really, is that traditional buildings are kind of designed differently to modern buildings. I was always taught when I was training that an older building is like a duffel coat and that it has to absorb some moisture and then it releases it gradually over time, whereas a modern building is more like a plastic raincoat, and it's designed to keep water out, but if it does get in, then it's kind of stuck. when these methods are mixed, so if you have a cob building which has then had concrete render applied to it, the building won't form properly and you'll have dampness, and with the dampness comes the cold. So getting the building working properly and as it should is a really important first step. Now, probably the easiest method of getting some gain here is insulation in roofs. Doing it at ceiling level is really easy, really cheap. You just have to be sure you maintain the ventilation into the roof void, basically, and you have to take care not to damage any lath and plaster ceilings that you may have. It's really important to avoid using like foil or plastic materials, again, because these older buildings are designed to breathe and there's supposed to be some airflow and some moisture release from that airflow. Whereas if you use these foil-backed materials, you don't really get that and it can lead to damp issues. So building regulations ask for a ceiling to have a U value of 0.16 watts per meter squared. So that measure basically is a measure of how quickly energy will pass through 1 square meter of a material where air temperature differs by 1 degree on either side. And you can easily reach that 0.16 with a lath and plaster ceiling with some sheep's wool or hemp fibre behind. So you can easily reach these building regulation measures using traditional materials, using traditional methods. Some things you do have to be wary of are making sure the insulation is correctly installed. So this is a picture taken from a house I used to live in the bathroom, and there was always constantly I was having an issue with mould on this section of the ceiling, and that's because there wasn't any insulation behind there. So the water was condensing onto that part of the ceiling because it was colder than the rest, and I'd constantly get this mould issue, and it occurred in other rooms in the house as well. So making sure the insulation is evenly distributed is really important if you want to avoid problems like that. Putting roof insulation above raft level is a lot more complicated, but does provide a very good seal. It's clearly quite expensive because you end up taking the whole roof covering off and relaying it, and it's not always going to be appropriate for your building. It's also going to likely to need planning permission, and if your building's listed building consent. Doing it between the rafters is another option, but you have to kind of measure your rafters and work out if you've got enough space to get that insulation in there. Something to consider when you're doing stuff in roofs is bats and birds, asbestos, all those sort of things. It's generally something, unless it's a very accessible open roof space, it's generally something where you're going to need a professional contractor to do the works, basically. And obviously, if you've got historic finishes in your roof space, so you may have torching, which is where the inside slates are plastered, basically, closed boarding. You may even have painted plasterwork or painted roof timbers. These need to be very carefully considered if you're considering any of these sort of works. Insulating walls to traditional buildings is hard. Traditional buildings obviously don't have cavity wall as modern buildings do, so you have a solid wall construction, maybe with some rubble infill, and it won't be uniform thickness, it won't be uniform density, so it's going to perform in an ununiform way, basically. If you're wanting to put external wall insulation on it, I generally think it's a bad idea, and it should be an option of last resort, really. The reason being is it's very expensive, and how do you detail it around window openings, door openings, where the wall meets the roof? It can also hide things like structural movement. It can affect the moisture movement through the wall, and it will almost always be a no for listed buildings, and it will require planning permission or a listed building consent. I did just see a question pop up in the chat. I'll have a look at the chat at the end and answer any questions I can. Again, internal wall insulation is very difficult to achieve because you're going to have to move all your skirtings forward, all your architraves forward, all your plug sockets. It's very tricky, and it's because it's so tricky and so complex, it's very expensive to do, and so you have a very low cost effectiveness with that method. In some cases, it could be 30 years or more, and it's something we consider doing at our offices at Exmoor National Park, which is Grade 2 listed, but very quickly came to realisation that it just wasn't going to work. It was going to be very expensive and complicated. So Floors can also be treated. So there's going to be two types generally, suspended timber and solid. There are issues with both, but there's benefits from both as well. If you've got suspended timber, then lifting up the floorboards needs to be done very carefully because they may have tongued boards, there may be hidden nails. You may have a lovely old patinaed floor, and if you're going to lift them and split them, then it's really best just to leave them alone, to be honest. And again, the way these buildings were designed, they need an airflow. So if you're going to insulate under the floor, it's very important to maintain that airflow, which can be done. It can be done in a number of ways. What you don't want basically is a sealed void underneath the floor, which if it gets damp, then you're going to run into issues with dry rot in particular. So covering the floor surface with natural fibre coverings and avoiding rubber back carpets and things like that is very beneficial. Filling in gaps between floorboard with floorboard slivers is a good move. And insulating under the floor is entirely possible. So this is a section through the floor, the top is the floorboard, these are the joists. And you can put insulation in that space and then have a breathable timber board underneath holding it in place. Or you can batten under the joists and have a permeable membrane holding the insulation in place as well. These sort of works are likely to require listed building consent if your building's listed, but again, I can provide advice, and every building will be slightly different. So this is just another method of insulating under a floor. Again, all these things are possible, but every building has its own issues, own intricacies. In some places, this won't be possible, unfortunately. Solid floors are a whole different kettle of fish, really, dealing with solid floors. So solid floors can be a very significant part of the character of a building, and taking up a floor and excavating below it can be damaging to the historic fabric. One of the main things to consider when doing this is the archaeology of the building, the depth of the foundation, and how the moisture might move under the floor once you've disturbed it. So this is a building in the National Park Grade 2 listed, and they applied to lift the floor and insulate under the floor, basically. And it was something I was a bit wary of, but we had very robust archaeological watching briefs on it. And actually, it's kind of changed my mind about solid floor insulation and how it should be approached. So when they took up the floor, we're talking about this room here, which is R5, in what is a medieval cottage. This is kind of where you'd expect the main living of the building to be. The cooking would take place in this room, so you'd have an open fire in the middle of the room. And that is exactly what they found. So this slightly darker brown area here is where the central hearth would have been, and there's a hearth stone still in place. And they found the post holes from what would have been like a cooking tripod of some sort. So, and then also in the other rooms, they found these stone-lined drains. So that there clearly had been issues with moisture movement through the building before, and it suddenly became a concern about how the works might affect that moisture movement through the building. So, although the result of the works is all this has been excavated, it has been recorded, and we now know a lot more about that building than we did before. So there is a benefit, but then there's also a cost, and I'll leave you to decide what you think is better there, really. But this is a very expensive project, and whether it's really worth the pain, I'm not sure particularly. So this is a section for a floor showing how it should be formed, really. Again, it's all about breathability. What you don't want to do is put a concrete slab in, basically, because the concrete slab will stop the moisture coming up through the ground, and it will force it into your walls, like the wall will act like a wick, basically, and just draw the moisture up, and then you'll end up with damp problems on your plaster on the inside surface. So it's all about the breathability of the floor. And you see there's a foundation not far below the depth of this floor structure, and often I've seen them have to go below the foundation and do underpinning when they're doing floor excavation to improve the performance of the floor. All these things are very expensive, very complicated. Is it worth it? Maybe, maybe not. A lot of the time, not. Windows and doors are probably the key point to all of these things, really. there's no point doing anything I've spoken about before if you're getting lots of drafts coming around windows and doors. And there are ways to deal with all of those. Pretty much all windows can be repaired and draft-proofed, I should say, sorry. So getting the window in good state of repair is the first course of action. Only if the window is really very rotten, especially in a listed building, should it be replaced. Draft stripping the window and then combining that with secondary glazing is hugely beneficial. And again, curtains and shutters and things like that help as well. So as Shirley mentioned at the start, we've had secondary glazing fitted to our office in Dolverton, which is grade 2 listed, and this is the system we've gone for. So basically, this is the sash window, which is open, and there's a perspex sheet which is magnetically fixed to the sash, so you don't have to take the secondary glazing off to open the window. It operates with the window, which is hugely beneficial. I live in a house which has secondary glazing and has these very clunky, clumsy screens you have to take on and off every time you open the window, and it really doesn't help at all. But this one opens with the window, so there's none of that messing around. And it also has a very good, something I didn't realise until these guys fitted this, is that if you have a secondary glazing set a long way in from a window, say 5 or 6 inches or so, then you're actually not going to gain much from that because the gap is so big, you don't get much insulation in that void. So the trapping of the air between the void is what gives you the insulation. Whereas if you have this perspex screen fitted onto the window, you have quite a narrow void, and that does trap quite a lot of heat. So it's actually much more efficient. At the same time as doing this, they also draft-proof the windows. So you'll see below his hand there's something called a parting bead, which he replaced with these ones with the brush strips, and also on the meeting rail as well, so where the top and the bottom of the sashes meet, that was draft-proofed. There's really quite little benefit in secondary glazing the window if it's still drafty, because that is where the majority of the heat will go. I can't remember the exact percentage now, but I believe it's something like actually 20–25% of the heat lost through a window is lost through the glazing. Most of it is lost through the drafts. So getting it performing properly and then doing secondary glazing is how to approach it. And they estimated on our sash windows, which are very big, they're 12-pane sash windows, that we may see a saving of around £200 a year in a few years with energy prices going up. So it does pay for itself. We're expecting this to pay for itself within the next 5 or 10 years or so. So you compare that to the external insulation, which has a payoff a period of 30 years. This is a really good key first step to take. Now, obviously, with metal frame windows, it's a bit more tricky. They are harder to repair. They are harder to draft proof. So you may have to have a secondary glazing sat in behind. This is a really good example of that. So this is actually a double glazed secondary unit which sits in behind, and then you retain this beautiful historic window with lovely catches. The building retains its character, but you effectively have a triple glazed window. So it is best of all worlds. There's always a solution to windows and doors, always. We often get asked about double glazing in listed and historic buildings, but I'll kind of focus on the listed building side here, because if you're not in a listed building, it's likely you won't need permission to change your windows, but it's always worth checking. But if you're in a listed building to change your windows, you're going to need listed building consent. And people often ask if they can use something called a slim profile double glazing. So a standard double glazing unit is about 24 mil thick, whereas these slimmer ones are more like 14 to 16. It was something which was pushed a few years ago as a solution to this problem, but they are now starting to create problems, because the issue being is that you have quite a thin sealant bead around the glazing, and they fail quite quickly, and then you get this kind of misting up of the unit, which looks really horrible and is very hard to deal with without taking the paint out. So I don't now really recommend putting in this slim profile double glazing because of this problem, and I will always suggest, and I'm doing it to my own house as well, where I have single glazing, that you get the window performing well and then you do a secondary glazing rather than double glaze it. So there's two issues really with UPVC. One is the aesthetics of it, and the other is actually the energy efficiency of it. So there's been numerous studies around energy efficiency in UPVC windows, and although they perform better thermally in the building, the amount of energy it takes to produce a UPVC window and the amount of harm caused to the environment for its production is actually far greater than for the production of a timber window. So although you may be making your building more energy efficient, you're actually, in one sense, causing more harm to the environment by using a UPVC window, which sounds kind of counterintuitive, but I'm afraid there's lots of studies showing that's the case. And it's also worth bearing in mind that although a UPVC window, may be cheaper than a timber window, if you have a good quality timber window and you maintain it, it will last longer than a UPVC one. People often think UPVC lasts longer, but if you live in a house which has UPVC from, say, the 1980s, the chances are you're looking at replacing it because it's reached the end of its life. Whereas if you have a timber window, these ones here on the picture on the left are probably original to the house, which is early 1900s. These timber windows are over 100 years old. Neighbouring properties now have unfortunately gone to UPVC, although they have respected the glazing bar pattern. The proportions are all slightly different, and it sits uncomfortably with the rest of the row. And it's really harmful where you have a row like this of kind of cottages which are formed as one, where one person goes to UPVC. It upsets the aesthetic quite dramatically. And as I've already shown on a couple of slides ago, timber windows can be repaired and you can do secondary glazing, so you can get all the energy efficiency benefits, cost savings, everything, and still maintain the aesthetic appeal. This is an example where sadly a window was beyond repair. It's a Grade 2 listed farmhouse, and I had various meetings out there with different joiners, and sadly we did come to the view that this window was beyond repair. So it's not always the case that they can be repaired. The reason being with this one really is because the arch heads, all this archwork had completely rotted, and these poor people were living with tea-towels and stuff wedged in on the windowsill to keep the drafts out. It was really quite grim. So I'm not saying timber windows always last forever, but they last pretty well, and those examples were a couple of 100 years old. So this is Lee Abbey, and unfortunately they replaced all of their windows with UPVC without permission about 20-30 years ago, and they are now failing. So the argument that UPVC lasts for a long time, it doesn't stand up. And these ones are all now failing, all very leaky, all very drafty, and they're actually going back to hardwood windows. We just had a list of building consent submitted to replace all the UPVC ones with hardwood windows, which is an excellent result. Right, so I'll move on to solar briefly. Things to consider really are how visible they're going to be and how much energy is going to be generated. Can they be located somewhere less sensitive? So if you have a listed farmhouse, for example, have you got a modern agricultural building around the corner where you could put the solar panels on? Also, what's the impact going to be on the fabric? So if you're going to have to be fixing into medieval roof trusses, that's really not ideal. So it might not be a solution. What you may not know is there is a Grade 1 listed building on Exmoor, which is also on top of a Schedule 90 monument in a conservation area, which has solar panels on it, and that's Dunster Castle. So it can be done on really highly protected buildings, provided that the location works and it's not going to be too visually harmful, basically. And we have policies that deal with that on Exmoor. And we were considering putting solar on our offices at the National Park, and it was something I was involved in. And basically, I discounted, unfortunately, the south-facing roofs, which are this one, the main elevation. At the moment, the national policy is that it's really not an acceptable approach to do solar panels on the main elevation of a listed building. So we couldn't do solar on the front, on the south-faced roofs, but we did have some less important roofs around the back of the building where the panels wouldn't be seen. But we had the solar auditor come out, and he said, yeah, you could do this and you would get some energy from it and it would be helpful, but your payback period on it, because it's such a limited area and because it's not facing, is going to be quite a long time, and your actual CO2 reduction is going to be marginal. So is it worth it? Because again, there is a cost environmentally in producing these things. So the cost of producing these solar panels, shipping them, putting them on the roof, has a CO2 impact as well. And if we're only going to get a marginal gain of electricity from it, is it worth it? And we basically come to the conclusion that it's not for our national park, for the officers. Air source and ground source heat pumps are increasingly being looked at. I can't remember what date the government's thinking of phasing out gas boilers, but I think it's 2040, something around then, which is very, very soon. and finding an alternative solution is really complicated. Air source and ground source heat pumps are still kind of in their infancy, really. I've heard that air source heat pumps are good if you're running an underfloor heating, but they're less good if you're doing a traditional wet system with radiators. But the technology is improving all the time. Things to consider are where you're going to locate it, pipe runs, archaeology, especially for ground source heat pumps, because there's going to be a lot of excavation for that, and noise, because they do make a humming noise, especially the air source heat pumps. And it's always worth checking with us if you're in the national park whether planning permission is needed or not. Generally, it will be, depending on where it's going to be fitted. But yeah, it's always worth checking. So this was an example of a National Trust owned property where they wanted to fit air source heat pumps, and they were proposing to fit them. This is kind of around the back of a building in the farmyard, and they wanted to fit them next to this door. And I went on site, and actually you saw that from quite a lot of positions in the farmyard, and they were going to use this door as kind of one of the key entry and exit routes of the building. And unfortunately, air source heat pumps are pretty ugly things. They're quite industrial looking. And so basically, the best option was to actually put it on these walls, which although was quite a minor change in position, still worked for them and was actually better for the building as well. This picture here is of the Historic England Energy Efficiency document on heat pumps. So there's a huge amount of information in these, and you can see this is an example of the ground source heat pump. So that's what I'm talking about when you need to take into account archaeology, because that is a massive amount of excavation. There's a couple of other things to consider as well. So replacing your boiler is really one of the most important changes you can make. If you've got a 30-40-year-old leaky gas boiler, then replacing it with an energy efficiency one will be a great improvement, and technology has really improved. And you'll probably be looking at something like an electric boiler now with the way things are going on. Generally, if you're in a listed building, you're unlikely to need listed building consent to change your boiler, but you might do if you're going to have something like that, an external flue. So it's just worth keeping in mind. Things like oil tanks as well may need planning permission. Electric vehicle charging points are again becoming more and more of a factor, and we're getting more and more requests for them. And unfortunately, again, it's the same with all these things. With air source heat pumps, with vehicle charging points, with solar panels, they're not the most beautiful things in the world to look at. And I don't know if any of you have been to Dulverton recently, but they've just put some car charging points near our offices, and they look like something that belong in a motorway service station and not in a conservation area. So, but unfortunately, it's kind of the way things are going. They're now talking about using existing lamp posts and things like that as charging points. So hopefully, technology will move on. Try and keep them discreet, basically, is the guidance, and think about cable routes and what signage or markings may be needed. LED lighting is something which actually has huge energy cost savings, and we're again going to do that on our office. And it was considerable amount it was going to save on our electricity bills. It was hundreds of pounds a year to go to LED lighting away from the fluorescent tube bulbs, basically. So that's something which is a very quick and fairly cheap fix as well. Just the last point really is consider where your materials are coming from. So it's all very well doing an air source heat pump and solar panels, but if they're being bolted together in China and flown to America to be to have some parts added and then shipped across to Britain, there's a huge environmental impact on that. So it's something to bear in mind, and there are, I think, the pushes that each country kind of becomes a bit more self-sufficient in producing its own energy efficiency measures, but that's going to take a while to happen. And it kind of goes back to my earlier point that a lot of older buildings were constructed of very local materials with local craftsmen with very low environmental impact. So although your traditional building might leak a bit of heat, in one sense it is very energy efficient in that it hasn't involved steel being dug up from a mine in China and smelted down and shipped around the world. So in some sense your building is really very, very energy efficient. And just my last slide is this very useful little wheel which I found online called the Responsible Retrofit Wheel. And you can plug in all sorts of things. So you can put in your heritage value, so it'll ask if it's listed in a conservation area or whatever. It'll ask what condition it's in. what sort of energy you're using. It will tell you really what's the best fit for you. So is it best to do your windows, best to do your walls, best to do your doors, and whether they have technical heritage or energy concerns. It's a really useful tool which I use quite a lot. Right, and I believe that is my last slide. So I will exit and I will hand control back to Shirley.
But that was absolutely fascinating, and you've given us some really excellent examples there. And of course, being an archaeologist, I was delighted to see that consideration of archaeological impacts on schemes as well, which is so important that we understand that. And in some cases, we can do mitigation, as you saw there, but in other cases, we might think that the cost isn't worth the process. But it's really important, as you've demonstrated, to get our buildings more efficient, working for people and for the climate as well. If people are interested in doing questions, please do use the chat. I can see we've got one already, which asks, you referred to tiled roof and insulation. What do you need to do if the roof is thatched?
Yep. So thatch roofs can be insulated, absolutely. Again, it's kind of each case to its own. So we may have some really amazing smoke blackened thatched roofs, which we want to do real minimal intervention to. I wouldn't advise fixing insulation to the underside of the thatch. I'd do it kind of at ceiling level, so above your joists. And again, try and use a breathable material. And you should also maintain some sort of airflow at the eaves. Which does sound counterintuitive because you're introducing an airflow into an insulated area, but that insulation will still provide a benefit. Thatch is actually very a very insulative material anyway, so it may not be something which is needed.
Right. Well, I don't think we have any more questions actually, Tom. So that looks perhaps give people a minute or two to
I work at National Park full time, and I'm able to provide any input to any questions you may have. So I have email address and phone numbers which we can share if needed. I just had a question about grants available. The situation with grants is constantly changing. Basically, there's no grants available from the National Park. Unfortunately, we're just not in a financial position to be able to do that. There are government grants. And there is a bit more of a push now. Devon has just been consulted about mitigation on insulation, and one of our main pushbacks was that people are going to need help with this, especially with traditional buildings, and where the government's coming up with deadlines to get energy efficiency ratings up on buildings, people just aren't going to be able to afford to do it without financial help. So I do think there's probably going to be some more grant coming, hopefully, fingers crossed. There is a little bit at the moment with the Green Homes, I think it's called Green Home Grant System. I can't remember the exact phrasing now. And so it's all online. The .gov website will have any government grants available. So it's best checking there. Yes, I believe my slides are going to be circulated and they've been recorded. I'm not sure where they're going to go. I think they might go on YouTube, possibly.
We'll make them available via the website, so there'll definitely be a link. We're still working out exactly how we're going to make it available, but we will definitely circulate everybody who's registered for the presentation with the link.
Yeah. Question on draft. Yes, a bit of draft is definitely a good thing. I live in a listed building and it has a wood burner, and I get quite a draft from under my front door, and I put draft proof, like a draft proofer under there, and then suddenly my wood burner wasn't burning quite as efficiently, and the house actually got colder because there wasn't a draft. And the draft acts as kind of an air circulation and dries the building out, so it kind of goes back to the breathability of the building. So yeah, a little bit of draft is a good thing, but obviously you don't want to be sat there wrapped in a blanket shivering. You can now have systems which circulate air. So I've seen somebody have an air pump in their roof, and it gently circulates the air around the building, almost like an air conditioning system, because they have very well draft-proofed windows and doors. So draft is a good thing, basically. Yes, a question about oil. A lot of Exmoor does run on oil. Yeah. Again, I really don't think this is something which is being thought about higher up. So I myself have an oil Rayburn, and because I live in a village without gas, and we want to get rid of it, but there's not really a cost-effective solution at the moment. I do think electric boilers are probably going to be what's pushed forward a bit more. And obviously you have this you could do for Calagas, for example, but that doesn't really solve the fossil fuel question, does it? So dealing with these rural areas, and there are a lot of rural areas in the country, not just Exmoor, that have oil, is very tricky. And I don't really think there's a solution to it yet without really improving the electrical supply. And then they're now pushing electric cars, and they're already getting feedback from the grid saying we're going to struggle as it is. So it's such a complicated issue. I really don't know if it's been properly thought out yet. Magnetic segment glazing, but condensation gets in. Yeah, condensation is caused by all sorts of things, really. It's how you're using that space, I suppose. If you're drying clothes inside, cooking inside, get wet pets, and it all adds to the moisture in the room. If you're getting it in behind your secondary glazing, it would suggest there's a gap somewhere in the magnet, in the seal. So I'd check the seals, basically. I'd get the window nice and dry, maybe in the summer when you've had a bit of a break from this horrible weather we're having. Get the room nice and dry, and then try and reseal that magnet strip.
Right, well that's absolutely excellent. Thanks so much, Tom. That was a brilliant presentation and so informative. You know, you've obviously mastered the subject, I think. So well done. I think that brings our talk to an end. I will stop the recording. And just thank you very much all as well for attending. And as Tom said, I think he's very welcome if any of you want to follow up any particular points with him. You know, do get in touch with the National Park, and we'll be able to put you in touch with Tom easily. And just like to thank Pat Watson-Mabbott and the HE team as well for help on the technical side. And we look forward to joining us on our 2 remaining webinars, which we'll be sending details for shortly. They'll be at same day of the week, Wednesdays at 12 o'clock. So I think we'll just say goodbye now, and hope to see you at those events soon. Thank you very much for coming.
Thank you. Bye.